It's my pleasure to introduce Steve Hanna, guest speaker for this afternoon, for simultaneously for CS38 as well as the ISTS speaker series. Steve has been a longtime collaborator and supporter of our security work up here at Dartmouth, and he's now at Juniper Networks, where he's a distinguished engineer responsible for driving security standards, co-chair of the Trusted Network Connect group within the TCG, active in lots of standards, lots of patents, made a lot of things happen. And I should point out that Steve got his education at a Ivy League college in Massachusetts. Nonetheless, we're happy to welcome here to talk about cloud computing. So, Steve.
Thanks, John. Yeah, thanks for welcoming me here in spite of my checkered past. I love coming up to Dartmouth. You have a great department here, great CS department, wonderful work, and very interesting student body. I love the way that the student body, the faculty, and the IT department all work together with the research institutes here at Dartmouth. So it's a very, very good way to do things, I think. And what I'm going to be talking about today is about cloud computing and about security of cloud computing. But I'll cover a few other things as I go along. I hope it'll be interesting and entertaining. And you'd better pay attention because I'll be asking for some audience participation at various points in the talk. So this is the agenda, the outline for my talk. Somebody asked me earlier, are you going to define what you mean by cloud computing? And certainly I am, because it's a very nebulous term. Nebulous? It's one of those IT buzzwords that goes around the industry, and you're never quite sure what people mean by it. And is it important or is it not important? Is it new? Is it not new? So I'll try to define what I mean by cloud computing, which is probably not exactly what other people mean, but we'll see. And then I want to focus in on security, since this is a security class. We do have to cover cloud computing and understand it in order to do a security analysis of it. But this is a security class, and so we'll do a security analysis of cloud computing. And then we'll try to draw some conclusions at the end about cloud computing and how suitable it might be for various applications. So that's the plan for today. Let's get started. What is cloud computing? Well, cloud computing, as I define it, is dynamically scalable shared resources accessed over a network. So let's break that down. Dynamically scalable. What do I mean by that? These resources, maybe they're compute resources, whatever they are, that you're going to access over this network, you only pay for what you use. It's like a utility. You know, you load your software up there, or you're going to use some software that's already loaded up there. And say you only use it for an hour today, you only pay for an hour's worth of usage. Use it intensively tomorrow, you pay for that. So that's what I mean when I say dynamically scalable. You pay for what you use. Now shared, what do I mean by that? Well, there are two models of cloud computing. One is where these resources are shared within a single organization, and that's what's called a private cloud. One is where the resources are up on the internet and they're shared by everybody on the internet, and that's a public cloud. So in any case, the resources are shared among a bunch of users, and that's how they're able to make this pay-as-you-go or usage-based billing work, is that they charge each user, each customer, according to how much they use. Now, when I talk about resources, as I said, this could be storage on the network that everybody's sharing. It could be compute resources, and you're running software on their compute servers. It could be services, so it's operating at a higher level. I'm going to have examples of all of these later on. And when I say it's accessed over the network, it could be an internal network, or it could be the internet that we're talking about, that you're using to access these shared resources. So these are the key components that make something cloud computing or not cloud computing. Is it cloud computing? It is, if it's dynamically scalable, shared among multiple customers, And if you're accessing it over a network, then it's cloud computing. So an example, Flickr. So that's shared resources. You post your photos up there. It's accessed over a network. You're sharing it with a bunch of other customers. In this case, maybe not paying for it at all. But another example, Gmail. So again, it's a shared resource up there. You're sharing it with other customers over the network. In this case, again, you're not paying for it so much as you're watching ads, and that's paying for it. But your payment, if you're making it, is generally according to what you use. Please.
So a key served program on that's cloud computing, right? It's available. It's on the server. I only access it at particular times. I mean, that seems like an old model, but that would fit this definition. Am I right?
Yes. And in fact, it is very similar to time sharing. So, I mean, you could go back 40 years and we were doing the same thing, right? And a lot of the same considerations that apply to cloud computing are the same ones that applied to time sharing. So you have some shared resources. You know, maybe you're accessing them with dial-up. 40 years ago it was dial-up lines. You were paying according to your usage, probably. Maybe not, but often that was the case, paying by the certain number of seconds that you were using the CPU or how much disk space you were using. And they were shared with other customers. So in that sense, you could say that time sharing 40 years ago, we were all doing cloud computing. The difference is that now we're able to do it on a greater scale. So we're able to have something like Google itself. That's cloud computing. They're providing a service over the internet, shared among a bunch of different users. It's just at a much more massive scale. So there's some real benefits to that. If you want to think about it this way, you're renting instead of buying. And all the same, we'll talk about later about when it's better to rent versus to buy. But the same considerations apply when you're renting a car as opposed and when you're renting CPU cycles. A lot of the same considerations apply. And the caveat I want to throw in here is that cloud computing is a new term, and so it's still being developed and defined and refined. And so you'll find other people using different definitions for it, although I think they're largely consistent with this definition. And I'm sure that it will evolve over time as people come up with new ways to do cloud computing. So who likes pictures? Everybody likes pictures. Let's look at this graphically. Conventional data center in-house at a particular organization. Here's your data center. You've got some data in there. You've got some applications in there. And it's accessed over the enterprise network or perhaps through some remote access technique over the internet. So that's your conventional data center. And how does it change when you move it to cloud computing? Well, all the stuff that you had in the data center before moves out here to the cloud provider. So your data and your applications just shifted over to the cloud provider. Your enterprise network may not have changed that much. You're just accessing resources that perhaps invisibly to the user are now provided by a cloud provider. As I mentioned earlier, you can have an internal cloud if you want. Say you're a really big organization. Well, Dartmouth might be a good example. You might want to have a compute cloud where people can submit jobs up there or access shared resources there, shared storage, and then it's all internal to your organization. But you get more scale and more benefits of scale if you have it shared worldwide. And another benefit that you get is that your remote users don't have to go through your enterprise LAN to get to the data center. They can go directly to the cloud provider, and if it's a really big cloud provider like Amazon or Google, they have massive data centers, highly available, very replicated, so you can get better access from anywhere in the world to your data and your applications. But there's something missing from this slide, the sharing part. There needs to be another enterprise in here as well, or at least there often is another enterprise, which is also sharing these resources. at this cloud provider. So, you know, this might be, oh, I don't know, Dartmouth, and this might be Harvard, or this might be Microsoft, and this might be Apple. In any case, it may be your competitors, it may be your allies. Who knows who else is using Google at the same time, who else is using Gmail, who else is using Flickr, who else is using Salesforce.com. It really doesn't make that much difference to you if everything's working right, who else is using that same cloud provider. If things are...
They will be using the same public internet.
Yes.
So we have a million of those enterprises.
Yes.
Something's going to happen.
Yes. So I have to repeat the questions because we don't have a mic for the folks who are watching the video. So the comment was that everybody's going through the internet, and how does it scale up when you have a million different enterprises who are all trying to access the same cloud and the same resources? The internet is designed to scale up to that level and beyond. The cloud provider, well, it varies from one cloud provider to another how well they're able to scale up. But one of the benefits of cloud computing, as you'll see, is that it is designed for scaling. And was there another question up there, Sergey?
So I was thinking of the MPLS
Yep.
As a way of an ISP to use their entire network as a cloud.
Yes.
The separation, I mean, there's peer sharing and separation. Right?
So the comment is that MPLS allows an ISP to use their network as a cloud. And I'll get to that in a minute. Network services as a service that you can provide in this shared manner and pay as you go. All right, so we've seen a graphic depiction. And please feel free to ask questions and comment, and that makes it a lot more interesting for everybody, I think. Helps keep you awake, too. So, and helps make sure that if I go down a bad path, you will steer me back. So following up on Sergey's comment, let's take a look at the different kinds of cloud computing that there are. So there's software as a service, and we've talked about a couple of these already. A network-based application may be provided on the internet, and everybody can access it, whether it's Gmail or Flickr or Salesforce.com. It is a website or even something non-web-based, although most things are web-based today. Everybody shares it. Maybe they store their data up there, and perhaps it performs some useful computations for them, transforming their photos from one format to another, or sending and receiving email, or doing something. It's a shared software application that everybody can access. And that was arguably the first, still is the most popular cloud computing, type of cloud computing. Simple and easy to understand. Data as a service. So the first one is called SaaS, and this one's called DaaS, and they're all sort of as, things like that. So data as a service. So the cloud computing provider provides a database, and the cloud computing customer, and I'm going to use these terms throughout, customer and provider. Provider provides the database, and the customer can query that database and can maybe not pull out all of the data in that database, but can pull out selected records from that database. So in general, this is some valuable data set that the provider is willing to give you access to on a record-by-record basis, and they're going to charge you by the record. So that's data as a service. Then there's platform as a service. And Amazon provides this, and so does Google and some others. So the idea here is you want to have a development platform where you can develop your own software. You're going to write your own software, and it's going to live up there in the cloud, and it's going to run up there in the cloud. And the benefit is you don't have to run the data center. Okay? Now, generally with platform as a service, they have their own custom application development environment, and you write in their programming language, not C. And it's designed to be massively scalable. It's designed to be parallelizable, preferably. That would be a good attribute in a cloud computing platform as a service environment, because that way they can scale it across their big server farm. If you want to run a job, you can take advantage of the fact that Google has thousands and thousands of servers, and so does Amazon. And they can take advantage of your your business because they have to have lots and lots of servers to handle their peak demand. And so Google and Amazon are basically renting out their servers when they're not in use, which is 364 days a year for Amazon because they need so many servers for the Monday after Thanksgiving. And the rest of the year, they don't need them. So they rent them out to you or me, and we can write software to run on them. And Amazon and Google, similarly, they have peak demand when people are, Googling a particular event. And so they run their cloud computing and their other services and share the compute resources among them. Infrastructure as a service. Now, this is similar to platform as a service, but what you give them is you don't write to their APIs. You write to whatever operating system you want, and then you give them a virtual machine image to the cloud provider, and they run that on their hypervisor, on their virtual machine hosting platform, for example. So that would be a computing infrastructure service. So you can load up your VM with whatever you want. It could be some software you wrote, something you bought. Maybe it runs on Windows, maybe it runs on Linux, who cares? You upload it to them, and they will host it up there. Maybe on its own machine, maybe you're sharing that machine with other customers. You don't really know, you don't really care, as long as your software works the way you want it to. And you can access that software, say via web interface, if your if the VM image that you uploaded has a web server on it, or maybe use some sort of remote desktop, and it looks just like a Windows desktop to you, and you're just running a terminal application on your desktop. Exactly how you access it remotely depends on what you've uploaded to them. So that's infrastructure as a service where they're providing compute service. The other option is they provide network storage, and then they expose a protocol to you, and you can upload files, download files, even mount their file system over the network and use it as if it was a network file system in your own organization. It's just up on their servers, and they charge you by the kilobyte, or the megabyte, or the terabyte. So we have a few more examples here. We're getting a little more obscure now. But pretty much anything you can imagine as a service has been done by one company or another. Identity and policy management as a service. Now that there's SAML and other federated identity capabilities, your users can go ahead and log into this service, and then it will provide single sign-on to all of your applications in-house or other outsourced applications that you might have loaded in other clouds. So that's another thing they can do. Network as a service, which Sergey talked about earlier, or asked about earlier. The provider, so maybe this is Verizon or AT&T or something like that, will provide what looks to you like an enterprise wide area network, with point-to-point links, but actually they aren't point-to-point links. They're just provided over a shared link. So it looks to you like you have a leased line between here and San Francisco, but actually it's going over a shared network infrastructure. Maybe it's all encrypted, maybe it's not. Maybe you have guaranteed bandwidth, maybe you don't. Depends on what you negotiate with your service provider. So all of these different kinds of cloud computing, and I think I got all of them, they all fall within that same definition of cloud computing. So dynamically scalable, shared resources accessed over a network. And they all have some pretty similar properties, especially security properties, as we'll get into in a minute. These are some of the providers, some of the different companies that provide these services. And I'm not going to go into them, but I'll just note that SaaS is pretty crowded. Actually, there's probably 100 other logos that you could load up there, as is this identity as a service, because people understand it's really easy to migrate your existing applications to infrastructure as a service, because you can just upload your VM to them, and they host it up there, and you don't have to change any of your software. So that's very attractive. software as a service is attractive for other reasons, as we'll get into in a minute. All right. So why do people want cloud computing? Is it just because they want to be buzzword compliant? No. The reasons that people adopt cloud computing, I think the foremost one is reduced cost. It's just a lot cheaper to let somebody else host your computing and your storage and to buy it by the minute, if you will, or by the kilobyte, than it is to manage the data center yourself. And part of that is natural. It's economies of scale. It's cheaper to run one data center with 1,000 machines than 1,000 data centers with one machine. You don't need to have nearly as many IT staff. You can afford to do more automation. You can afford to site your data center in a more efficient location. You can afford to do all sorts of things that you couldn't afford to do if you're just a small enterprise. So there's reduced costs. It can all be outsourced to some low-wage country is another possibility. Resource sharing is more efficient. And this is, again, goes to reduced costs. Maybe it's just this year that we're all thinking about reduced costs, but actually I think it's been for about the last 20 at least. So like I was saying, it's more efficient for Amazon or for Google to share their resources with you, and then they're getting paid by the minute when you're using them, and they're not just sitting idle. The same is true for you. It's cheaper for the customer, instead of buying enough servers for the maximum load they're ever going to need and then having them almost always sitting idle. It's cheaper to rent the time on a shared resource. A cloud computing provider, I've seen statistics that only 5 or 6% of CPU utilization in most enterprises runs around 5 or 6%. So about 95% of the CPUs that you have out there, of the cycles that you have available, are unused, and most of the power is wasted. So it's more green, actually, you could argue. Well, it's not, I think, a driving reason, but it is more green to use cloud computing. Also, all the headaches, those are now the provider's headache and not yours so much. Consumption-based costs, so you only pay for what you use. And from a profit and loss standpoint, that works out pretty well, because usually if you're using it, you're doing so because somebody's paying you. So then you don't mind paying a little bit for the compute resources you need. Whereas if you have to have some big capital expense to buy the equipment, you may not have the business to support it. So it's also that it's faster to roll out new services. In a lot of IT organizations, rolling out a new service involves going through a whole bureaucracy, and they have to maybe acquire some more equipment, and that takes months, and they have to see if they have the budget for it, and then they order it, and they bring it in, and they configure it, and they set it up, and 6 months later, you've got that new application you wanted to load, or you wanted to set up. If you're using one of those software as a service companies, you can give them your credit card, and 5 minutes later, you've got what you want, and they can scale it up from there. Also, if you tend to have quite variable usage, then you'll be able to, and perhaps unpredictable usage, you'll be able to scale right up when you need it, because they have thousands of servers. Whereas if it all has to be in your data center, you just can't scale that fast. There are some downsides to cloud computing, though, and there are a variety of them. Compliance or regulations or laws that might require you to keep all of your data on site, like, for example, HIPAA or European Union data privacy laws. There are security and privacy concerns with cloud computing, which we'll get into more later. Latency and bandwidth issues when you're going across the internet, that's a concern or can be a concern. Absence of robust service level agreements, that's what SLA stands for. So can you really count on that cloud computing provider to be there when you need them? If you're putting mission critical services up in the cloud, you'd better be able to count on them being there when you need them. And will they be able to interoperate as well as you need? Are they going to lock you in? That is, If you go with platform as a service and you write your own software to their platform, then they go out of business, then you're totally stuck. So that's definitely a disadvantage there. And so availability and reliability in general are concerns. And so in spite of those concerns, a lot of people are using clouds today, cloud computing. And I threw in a few examples here with some URLs so that you can go and check them out later on if you want to. One example is Mogulus. Mogulus, they provide a live video broadcasting platform on the internet. And so you can set up a camera at a sporting event or a school play or on-site reporting, whatever it is you want to report on, and you can broadcast live over the internet. Now, setting up your own live video streaming system would be a pain in the neck. And so you can use theirs instead, and you just have to upload your one stream to them live in real time using their software. And then they take care of relaying it out and broadcasting it to everybody else using a flash player. So that's nice. But what's especially nice is that they're able to scale up really quickly. So on election night, they were able to scale up to 87,000 simultaneous streams. And I have an update to this slide. I heard that on Inauguration Day, they were able to scale up to 100,000 simultaneous streams, which is great. For those of us who are trying to stream our kids' play or whatever it is, that'll be more than adequate. And if you were trying to stream like this lecture, that would still probably be more than adequate. Although who knows? Could be a big hit. In any case, it's really valuable to be able to scale up as you need it, but only pay for what you actually need, because it's sometimes hard to predict whether a particular lecture is going to be a big hit or not. So another example is Animoto. Animoto, these folks allow you to, I should have included one of their videos in here because it's really pretty cool. They allow you to take your photos, and they could be photos you've already uploaded to Facebook or Flickr or whatever, and they will make them into a video for you. And they do all this cool stuff. The pictures fly in, and they have music, background music, and you put subtitles on it and stuff like that, so it's pretty cool. And it's all cloud-based, of course, because why not? They were developing a new application, and they could take advantage of these, the cloud, and they never had to set up their own data center that way. The story here is that they came up with a great idea to release a Facebook app so that you could get your photos off of Facebook and turn them into videos. And what do you know? It was a big hit. Surprise. Surprise to them. They thought it would be a hit. They didn't know it would be such a huge hit, and they had to scale up in 3 days from 25,000 users to 250,000 users. That's a massive scaling problem, and that could have been what we call in the industry a success disaster, which is when you have such a big success that it's really a disaster because it overwhelms everything. And we've seen plenty of those, certainly, in high tech over the last few years with the internet. Well, fortunately, because it was cloud hosted, they were able to scale up. They went from 50 to 3,500 servers. I think everybody, not only did they have more users, everybody was trying to make their videos at the same time. So they had to scale up by a factor of 70 in just 5 days. And then, well, it was sort of a flash in the pan. They scaled back down to 100 servers later on. Not that they don't still have those users, I'm sure they do, but everybody had gone out at the same time, hey, let me try it, and they had to have the capacity to scale up. And then everybody was like, yeah, I tried it. Okay, I'll do one every week or two or something like that. So that's just a graph to show that, massive uptake that they had in terms of activity over those few days, those 5 days after they introduced the Facebook app. And if they hadn't been on a cloud computing platform, that definitely would have been a disaster. So is it all small businesses and startups that use cloud computing? Certainly not. Big organizations like New York Times use it also. They have something called Times Machine, where you can look at front page. Actually, I think it's all the pages of New York Times for any issue back to their first issue. If you're a subscriber, you can see them all online with PDF in PDF format. Well, they didn't have this service yet, and the guys inside New York Times said, you know, this would be great. We could do this. We've got them all scanned. We just have to make them available on somewhere on the internet. You know, and they went to the IT department, and the IT department said, are you kidding? We'd have to buy all these servers. We don't know if anybody actually wants to use it. You know, what a pain in the neck. Go away. I'm sure they had a long memo to that effect, in other words. So the folks who came up with the idea said, well, OK, we'll go out. We'll find a cloud computing provider. We'll upload all our PDFs to the cloud computing provider over the weekend, which they did, and cost them $50 to do that. And you know, then we'll just put this small front-end application on it, and we'll see. Maybe it will be a total flop. But you know, we only spent $50, so not a big deal. And turns out it was not a big flop. It was quite popular. So you can go see, like, there's the Titanic sinking there. Or not sinking. Looking actually pretty good. I guess they couldn't get a picture of it as it went down, but too late at night. But anyway, and even big companies like Eli Lilly are using cloud computing. Now, they moved their whole R&D environment out to the cloud. Yeah, there might be a few security issues there. Can't wait to talk about the security issues. But there were reduced costs. So there was definitely that benefit. And also, they're more nimble now. They can add a new VM very quickly since it's all automated. OK, so startups are using cloud computing for all sorts of things. Mid-size enterprises, somewhat. Large enterprises, not so much quite yet. They're sort of, a lot of them sitting on the sidelines. And now let's get into the security analysis part of the talk. So conventional process for doing security analysis. How many people are familiar with ISO 27005? No? I didn't think so. It just came out over the summer, and it codifies the traditional information security risk management process, which I'll just describe here in brief. First, you establish the context and the environment and the policies and the politics of your organization and your risk tolerance and all the rest. Then you perform a risk assessment, and that involves a few steps. First, you're going to identify the risks. Now, what do risks have to do with security? Anybody have a comment on that? No. Well, yeah. I don't think you're going to come up with a wrong answer. There are like 10 right answers to this question. So, very good. Figure out what you need to protect and how you're going to protect it and why. And yes. So you need to identify the risks, and the risks involve identifying the assets. What are you going to try to protect? Identifying the threats. What are you protecting them against? You need to look, in this case, at existing controls. What protections do you already have in place against those threats? And vulnerabilities, that is the gaps in your armor. So now we've identified, you know, what are we trying to protect? Who are we protecting against? What is the pieces of armor that we've already got in place to deflect those attacks? And where are the gaps in that armor where those attacks can get through, right? So that's good. So now we have to look at the gaps, and we say, you know, OK, there's a gap here. It's about this big. What would happen if this vulnerability, this gap in our armor, was exploited? What would that do? Would that kill us or just maim us, you know? Would it just take the website down for a little while? Maybe it wouldn't even take the website down at all. Maybe it would only take it down for people in one country. Maybe it's nothing to do with website at all. Maybe they'd extract our customer database and you know, sell it to our competitors. Or what would be the consequences of somebody exploiting a gap in our security? So now we've done a pretty good job of identifying the risks, and we have to estimate those risks. How likely is it that that particular vulnerability is actually going to be exploited? Yeah, well, that's pretty hard to predict, actually, when you start to think about it. How do you predict what the likelihood is that somebody's going to find that particular hole? You can probably estimate what the dollar cost is going to be if they exploit it. Even that is somewhat questionable. But you want to do some sort of guesstimation of what the magnitude is of those risks. Then you want to evaluate the risks. Gee, is that something we can live with? Or is that like a huge disaster and we have to solve this problem? And then you want to develop a plan for how you're going to handle those risks. And generally, there are 4 options for handling risks. You can reduce the risk by applying an additional control. So we put another piece of armor in place. Maybe we put another firewall. Maybe we use encryption somewhere we weren't using encryption before. Or maybe we have a process-based risk control, rather, and we train our operators not to just give out their passwords over the phone, or whatever the risk is that we're protecting against. So that's a way to reduce the risk. That's a good thing. If you can do that for a reasonable cost, that's often the best way to address a risk. But sometimes the cost would be outrageous, or it's just not practical to put a control in place, in which case sometimes you just decide that you're going to live with that risk. Well, yeah, there's a chance that 6 people on our staff could all simultaneously collude and attack us in this particular manner, and we have some controls in place, but what if the guy who was watching the controls was also in on the job? And there are some risks that you have to, in general, just be willing to accept or retain. Sometimes you decide that you're just going to avoid the risk. You take a look at all the things and you realize there's nothing we can do. There's a huge hole in our armor. There's nothing we can do to fix that hole. And if somebody exploits that hole, they're going to destroy our entire organization. That's a huge risk. We can't do anything about it. But we realize that we don't really need to do this project at all in the first place. I mean, it was sort of a nice idea, but now that we realize that it's a huge security problem and that we can't do anything to solve that problem, we're going to avoid the problem entirely by throwing the project out the window. That sometimes is an option. Not always, but and not often. The last is to transfer the risks, and that is generally where you say, I want to make that somebody else's problem. So think, for example, about your house burning down. There is a risk that your house could burn down. And you generally apply all of these different techniques, or at least some of these different techniques. You reduce the risk by putting in some smoke detectors so that you might be able to catch the fire before it gets too far. Or if you're all sleeping, at least you're going to wake up and get out of the house so you don't die, right? That's good. You retain some of the risk because there is always still the risk that your house might burn down. You avoid the risk, well, I suppose you don't play with matches in your house or something like that. And you transfer the risk. That's really what you do with most of the risk with respect to house fire, is that you get insurance. And you make it somebody else's problem, and you say, yeah, it's a rare enough event, but catastrophic, that I'm going to participate in an insurance system, and I'll just send them my premiums, and we'll make it their problem that house fires do sometimes happen. So you use a combination of all of these. In general, in any information security risk analysis, you use a combination of all of these techniques. You reduce a bunch of the risks by putting in place controls. You accept some of them, or retain them as they call them here. Maybe you avoid some of them, and maybe you transfer some of them, although getting insurance for IT security is difficult. You may be able to outsource some things, and then you've somewhat transferred the risk. The problem with transferring risks is that even if you do transfer the risk to your insurance company, if your house burns down, that's still a royal pain. Even if everybody's fine because you put in smoke detectors, and even if you get a check in the mail a few months later for the amount of, I don't know, some hundreds of thousands of dollars, the full replacement cost of your house, it's still awfully unpleasant to have your house burned down. So finally, you have to go back to management. You say, here's what we're going to do. And then they say yes, or they say no. And then you implement it and you monitor. So are we today going to apply this entire process to cloud computing? No. No, that's not really possible today. We don't have time for that. It would take hours. It would actually probably take weeks. And we don't have a lot of the things that we would need. We'd need to have the right context. Like, what exactly are you going to use cloud computing for? Risk management is totally different when it's your personal email or uploading some pictures of your family, as opposed to putting your customer database up there. Or, I mean, we can't really do this process. But what we can do instead is a streamlined security analysis process. And this is actually something that is very useful anytime you're trying to just get a quick idea of what the security issues are. And anytime you don't have the proper context because you're evaluating something in a context-free manner, saying, like, cloud computing in general, what are the risks? Not just cloud computing for my particular application within my particular organization with this particular, customer database. We're just asking in general, what are the risks of cloud computing and how can they be addressed? So you still need to identify the assets and what properties of those assets you're trying to protect. You need to identify the threats, and you need to identify the countermeasures. Still those three basics, but you just leave out all the part where you estimate the financial cost and decide exactly which countermeasures you're going to employ or not in any particular environment. So we'll go through those three steps. That seems manageable. And in fact, that's what a lot of times you end up doing for security analysis, because if you're not hired by a particular customer to solve a particular problem, but you just want to do a broad analysis, this is about all you can do in terms of security analysis. So if you look through any RFC that has a good security considerations section, you'll see that it covers the assets, the threats, and the countermeasures, because they don't know how you're going to use their protocol in your particular environment. It's up to you, the customer, to decide which countermeasures they deploy. All right. This is going to be a group project. Not that I don't have all the answers. It's sort of like Julia Child, right? Have you ever seen any of her shows? Old cooking shows. But anyway, she'd say, and this is how we make the chicken. And then she'd pull it out of the oven, and it's all done. So you're going to make the chicken, but I've already got it all done in the oven. So let's identify the assets. OK? So here was our conventional data center. And we have the data and the applications up here and the users over here, and they were accessing their data. And then we moved to cloud computing environment. And the data and the applications are up here, and the users are down here, and we're sharing with this other enterprise. All right? So my question to you is, what are the assets that we need to protect in this environment? Yes? OK, so that's good. The answers were application availability, application privacy, data privacy, and application integrity.
Data integrity, data privacy, application availability.
Thank you. It would be nicer if we had a second mic. Data privacy, data integrity, and application availability. Yes. Well, I think you're doing a good job to start. But I just want to identify the assets, not yet which attributes of those assets. So let's just take data and applications from your answer. Yes?
Can I ask a clarifying
Please.
question? Which is, if I'm Enterprise 1, I don't necessarily know who Enterprise 2 or anyone else is.
That's right.
Okay.
And the question was, if I'm Enterprise 1, I don't know who Enterprise 2 is. That's right. Or Enterprise 3 or Enterprise 4 or Enterprise 99. You don't know who else is using the same cloud. So we definitely need to protect the data, and we need to protect the applications. We don't want anybody else mucking around with our data and our applications. Got to protect those. Any other ideas? Yes?
I guess what she might have been getting at also is the protecting the identity of other people using it, because that can give away. I mean, Apple's doing a ton of computations. You can take some guesses at their big
Yes.
products.
Yes. So protecting your own identity could be crucial. That's true. Any other ideas for assets that we might want to protect here in this picture? Bandwidth, yeah. And anything else? Yes. these machines here, the client devices. Yep. And say more. In what could happen to those machines?
You want to be careful that they don't access data that corrupted that has viruses.
Yeah. You want to make sure that those machines don't get infected somehow or corrupted. So I think we've identified a good set of assets to protect. Should be writing these up on the board. There we go. So we had the data, applications, we had the network or bandwidth, and we had the client devices. Did I leave anything off the list? Identity. Yeah, well, that's, I think, under network. And we're not trying to protect the internet necessarily. It'll have to protect itself. Identity, I think, we'll lump in here into applications. Which devices? These ones or these ones? The cloud devices, again, I think those are their assets, not our assets. So if their assets get trashed, well, as long as our applications and our data are still okay, and our users are still okay, and their devices are still okay, well, I'm sorry that Amazon and Google lost, some of their machines. But okay, let's move along. So the ones that I had identified were the data owned by the customer, that is the person who's hiring the cloud, the applications, and the client computing devices. I hadn't identified the network, so let's make sure we come back to that one. That'll be an interesting discussion. So which properties or principles would we apply to these? What about these assets do we want to protect? And I'm just going to ask the question first in a broad sense. What kinds of attributes might we be considering? I put a hint up there, triad. Can you think of any? You had a couple already, actually. Would you mind repeating them? Yep. Confidentiality. And you had a third, I think. Yep, I think you did. Confidentiality, integrity, and availability. So those are the three basic principles or properties of information security, and they can be applied to, in one form or another, to all of these. So let's take a look at those three. I think you probably have covered this already in this class, and let's not spend any more time on it. But those three properties are things that we're going to want to protect for all three of these, or at least potentially. So for customer data, why do we want to protect the confidentiality, integrity, and availability? Well, we upload some data there, and it's probably confidential, or parts of it may be confidential, and we don't want it getting out to our competitors. Remember what she said, that we don't know who the other customers are of this cloud, and probably they include our competitors and maybe some hackers and all sorts of people that we don't want have access to our data. So we want to protect the confidentiality of that data. Do we want to protect the integrity of our own data? We want to make sure that it doesn't get modified in unauthorized ways, certainly. The availability of our data, is that important to us? If we care about the data, then we certainly care that we be able to get to it and use it when we need to. So we need to be able to protect all three of the properties for data. For applications, could it be that our applications are confidential? Yes, certainly. Our software could be confidential. What operations we perform, what processes we use in our organization, those could be confidential. Do we need to protect the integrity of our applications? Yeah, we don't want somebody else changing them. The availability of our applications? Yep, if we really care about whatever we're doing in the cloud, that's important too. And for the client computing devices, well, the devices themselves, there's potential we need to be able to protect their confidentiality, certainly the data that's stored on those devices. We need to be able to protect the integrity of those devices. We want to make sure they don't get infected. We want to make sure that they remain functional and available. So we need to protect all the properties for these three. With respect to the network itself, now would you say, one could consider the internet, but let's forget about the internet because in general that is, again, somebody else's problem. But our own corporate network, the confidentiality of that network, well, I suppose it could be relevant that we want to protect the structure of our network, certainly the confidentiality of the data on the network. Integrity of the network, integrity of the data on the network, yes. Integrity of the data that flows through the network, yep. Availability of the network, certainly. So any attacks on our network that could cause it to disclose data that it wasn't supposed to disclose, or to parties it isn't supposed to disclose it to, cause it to modify data in ways that it isn't supposed to, or cause it to be unavailable, I would say those are all of concern. So I would say for all of these, all three properties probably apply. So we've identified the assets and the principles that we want to apply to those assets. Now let's take a look at the threats. Any thoughts about, say, threats to our data? Our data is up here in the cloud. How could some bad actor, maybe one of the other enterprises sharing this cloud, how could they threaten the confidentiality or integrity or availability of our data? Yes, the cloud provider takes one of its disks out of commission and sells it on eBay, and somebody buys it. Absolutely. So would that which of these properties would that attack? Confidentiality, okay. Any attacks on integrity of the data? Anyway, and can you imagine anybody? Oh, there's a new version of Firefox. Great. Can you imagine? That might be able to weave that into the talk somehow. Can you imagine any way that somebody might be able to modify our data without our permission?
Depends on what's in the data. I mean, if there's something revealing in there that allows them to compromise your system, sure.
Okay, so say I stored up there, I don't know, the Yeah, well, this is integrity of our data. Let's say that I stored up there the source code for the next version of our operating system. And then somebody was able to go in there and introduce a few backdoors, right? That would be bad. Now there are backdoors in our operating system, and somebody's going to be able to break into our system. So that's just one example. But if somebody can change our data that's living out in the cloud provider, that's really bad. Can you see anybody in this diagram? Could another enterprise maybe somehow be able to change my data up in the cloud provider? Could that possibly happen? Yeah, it could. If the cloud provider doesn't have good separation, could the cloud provider be able to change my data that lives in the cloud? Certainly, absolutely. He owned it, he's got it up there. It's on his disk. So exactly. Somebody else comes in here, they find a vulnerability in one of the cloud providers' security systems, and they're able to get in and change my data. What about availability? Could somebody delete my data? Yeah, all the people we just named who could change the data could delete it just as well. And with respect to applications, I think the same vulnerabilities apply. As the same ways that people could get access to the data to read it, modify it, delete it, they could do that with respect to applications. oops. Network.
Well, something that on
Oh, yeah.
availability of applications, when you go from running things on your own machine to a cloud, even within the enterprise, let alone somewhere else, now I can't open my application. I used to be able to, but just environmental failure, temporary partitions of the network suddenly become availability issues, which hadn't been issues before.
Yep.
How different really is data applications? Because an application is not
Well, you're
a
asking
bit of
somebody who went to
data
Harvard, so.
sitting on the cloud server, right?
Right. It's all data sitting on the cloud server. It's just a question of whether it's executable or not. Right.
Making a Harvard architecture joke. Sorry about that.
So yeah. So it's all data in a certain sense. So the network. Oh, keep hitting the wrong button here. This is a 90-minute class, is it not? Yes. Just saw 2 people leave on the hour. So those must have been guests who came and only had the hour free. Thank you. So with respect to the network, I think we already said that well, if we're only looking at the network here, certainly the internet, I think we can agree that confidentiality, integrity, and availability are all things that can easily be compromised for data that's flowing over the network. With respect to data that's inside here, or with respect to this enterprise LAN, could the confidentiality of data on this network be compromised as a result of moving from the data center to the cloud model? Potentially. Maybe they're able to infect one of these machines that's on the enterprise network, and it's able to, monitor, snoop traffic, and send it off the LAN. Maybe they're able to even some other enterprise is able to compromise our user here, and that is able to compromise one of the critical network components, hop, skip, and a jump. You could be more vulnerable to network attacks or attacks on your enterprise network, I'd say. Yep.
Would it be silly to consider the fact that Enterprise 2 could let a worm or some kind of malware onto the cloud, and it then gets back into Enterprises 1's software, data, whatever, and then it ends up on the enterprise network?
Absolutely. That's not silly at all. The question was, what about a worm that could spread purposefully or accidentally from Enterprise 2 through the cloud provider and back into Enterprise 1? Not silly. Very reasonable. And that could influence the availability of this LAN, flooded with worm traffic. Yes?
So if my data and my applications are exposed to all these threats, should I keep a second copy of that data and application locally or on the cloud?
Okay, the question is, if my data and applications are exposed to all of these threats, and we've identified quite a few so far, and we still aren't done, maybe I'd better keep a backup copy of my data outside of the cloud. That might be a good idea, but does it completely protect you? So that's a countermeasure. That's a countermeasure. Is that a good countermeasure against breaches of confidentiality for your data? No. Why not? So your data gets leaked out of the cloud. Doesn't help that you have a backup over here, because the problem is that it's been leaked out to your competitors or somebody else. So it doesn't help with confidentiality attacks. Does it help with integrity attacks? Yes, only a little. So if somebody modifies your data and you don't notice, and then you rewrite your backups with the modified data, that's a problem. And probably you wouldn't notice. It's very hard to notice those sorts of things. One bit got changed somewhere. Does it help with availability? I think it does. Because if your data gets destroyed here, at least you have the backup you're able to recover. I mean, it's a good practice. It's not going to keep you up, 100% of the time, but you have the ability to recover from the loss of your data out there. Yes? Doesn't it defeat the purpose of cloud computing if you have to keep backups? Is that the question? I don't think so. I think there's still value in having your own backups, even if you're going to put your data out here and host your applications here. So let's take as an example, the New York Times example that we had there, Times Machine. And they wanted to have massive scalability in their Times Machine so anybody could go and access the data. Did they keep a backup, do you think, of all of the pages of the New York Times? Probably. They probably still have the paper, and they probably still have it on DVD somewhere. And that's a good idea, because maybe someday the cloud provider goes out of business, and they want to rehost it to another cloud provider. They could do that pretty quickly and easily if they have the DVDs. But if they threw away all the DVDs because it was out in the cloud, you know, they're really going to be bumming. And they haven't lost anything by keeping the DVDs. It's just a few DVDs in a safe somewhere or wherever.
The efficiency savings are not in the storage of the DVDs, it's in the servers that host the access.
Good summary. The efficiency savings are in having those scalable servers.
Is that true for all applications? Like if Facebook were hosted on the cloud and their data were lost, they'd be toast. Their software is nothing without their data.
Right. I think keeping backups is a good practice in pretty much any case, whether you're cloud hosted or not. So the client devices. Let's see, we were talking about threats here. Yeah, we've gone through quite a few threats, and I think we've covered threats to the client devices as well. So I'm just going to put up the threats that I thought of. This is the pre-baked chicken here. So failures in provider security, attacks by other customers. Let's run through them one by one, and we could talk about each one. And you could probably elucidate and come up with other expansions of these threats or new ideas. That's the great thing about security, is there are always more threats and usually more countermeasures than one person can think of. So that's what makes it interesting. All right. So failures in provider security. Basically, the provider, you have to trust the provider for quite a bit here. The provider hosts your data and your applications and controls them. They control the server. They control the network, at least within their cloud. And if they mess up from a security standpoint, they don't manage their cloud properly, all sorts of bad things can happen. There can be data breach, and they can breach your data out, you know, give it to your competitors accidentally. They may not even know that happened. It can be modified. It can become unavailable. There are all sorts of bad things that can happen. Even if, you know, there's one bad guy who works for the provider. You know, somebody's on the take, you know, gets bribed by your competitors to give your data out, or sells your data to the mafia, and they start making use of your customer credit card numbers. I mean, there are so many bad things that, you know, can happen in this area. The good news is that providers have put a lot of effort into their own security, and they have, of course, they have great physical security. That's not a terribly hard thing to do. So you ask a cloud provider about their security, and they're going to show you their bulletproof glass and their, you know, 3 checkpoints that you have to go through with biometric, you know, Tom Cruise kind of things that you couldn't get past if you had a Hollywood studio behind you. But that isn't really the hard part, right? I mean, that's hard and that's interesting and that's showy, but how have they done on the information security? Have they really, are their machines really well maintained, well patched? Are they running secure operating systems? You know, are they vetting their administrators? Are they monitoring their security of their systems? Are they requiring multiple administrators to gain access to the plain text of customer data? You know, all sorts of questions like that. So that was a lot of questions to ask, and it's a lot of questions to get answers to. So one thing that cloud computing providers are doing is to get outside verification by independent auditors of their own security. And that can provide greater assurance that they are actually running a secure shop. It's also worth pointing out that if you're a small or medium-sized business, whatever they're doing is probably better than what you're doing. You probably have, you know, everything on a PC in the closet that's acting as your server. and it's probably easily accessible from the internet once somebody gets through your link sits firewall. And there are all sorts of bad practices. You probably aren't even making backups. And even if you're a mid-sized business, you may think you're making backups, but they probably aren't working because you haven't actually tested them. And who knows about your IT security guy and whether he's on the take, and there's only one of them, so you have a single point of failure there. So if you're a small or medium-sized business, it's quite likely that the provider security exceeds your own. So yes, this is a big concern, but maybe you shouldn't be quite so concerned about it until you look in your own house. Yes? Yes, I believe they had a RAID system, and that was what they were depending on for their data availability. They didn't need backups because they had a RAID system, and so the employee came in and deleted all of the data from their RAID system, which automatically replicated that deletion across their entire RAID system and rewrote it. So then they had replicated nothing, and they hadn't done any backups. So that's what I heard. I'd say it counts as a cloud provider who screwed up on behalf of their customers. Yeah. And those customers, if they had backed up their photos or whatever data had stored with the cloud provider, would at least have been able to recover their own data. But still, it does make one question the reliability of cloud providers. I think we get to reliability a little later on. So what about attacks by other customers? Let's assume that the cloud provider is totally on the up and up, and they run a pretty good shop. These other customers are sharing the same CPU as you, and they're sharing the same storage as you, and they're sharing the same network as you within the cloud computing provider and also on the internet. It's the job of the cloud computing provider to provide separation between these different customers, to make sure that the data is separated, the applications are separated, that they don't even see each other's data passing in the hallway, that it's totally separated. Now, if the cloud computing provider can't provide adequate separation, then one customer is going to be able to get access to another customer's data or modify their applications or interfere with their applications. So fortunately, cloud computing providers, this is where they've put a great deal of their emphasis, somewhat into their own security and also into separation in particular. They tend to use hypervisors for separation. That's not absolute, not as strong as actual separate machines, but pretty good. They use network separation techniques, use cryptography to separate different data as it flows through their network. So they certainly have put a good deal of emphasis on this, a good deal of resources on it, and I think they've probably done from what I've been able to determine, I've talked with several of them, they've done a pretty good job of it. The one area that causes me some amount of concern is some of the SaaS providers, software as a service providers. They don't actually provide strong separation between the different customers. They just store everybody's data in one common database, and then they have application layer controls. So the application software says, oh, well, you're not allowed to see this picture, you're not allowed to read this record in the database. So if you can, in that case, if you can corrupt or otherwise subvert the application layer controls, corrupt the application or otherwise subvert it, you can get access to things you shouldn't be able to get access to, because they're not using cryptographic separation, just application layer separation. One buffer overrun and they're out the window. So how about availability and reliability? This is definitely a big concern. People don't always think about availability when they think about security. Well, that's not our problem. That's availability. That's high. Well, actually, it is. It is a security concern. If you think about distributed denial of service, that's all about availability, about destroying the availability of a system. So Perhaps clouds are less available than in-house IT. Google has been down a few times in the last month, 4 hours, 8 hours. The Gmail, excuse me, has been down a few times in the last month. One can argue that they're more complex, that in order to get there you have to get across the internet, and internet has its bad days. Cloud providers have focused on availability. They can't really control the internet's reliability very much. But they're even starting to work on that, to work with the ISPs to give you guaranteed access to that cloud computing provider. They offer often service level agreements. We'll reimburse you part of your bill for this month if the internet, if you can't get to our service, which doesn't always help if you're trying to close a deal or solve some problem, and certainly accessing patient data and the patient's dying and you can't get to the service. Well, getting $50 back in your check at the end of the month really wouldn't help much. But they certainly are focused on availability. I don't think they've been quite as successful as with respect to the other things we've talked about. So you should probably look at your provider's availability record and see how they're doing. And you might want to think about not putting those sort of life or death applications up in the cloud because the internet might be having a bad day, or so might the cloud provider. They hate it when I say that. Okay, legal and regulatory issues. What are the issues here? There are all sorts of laws and regulations which, depending on your organization, might prevent you from using cloud computing. And some of these are security and privacy related. And so those need to be taken into account. This is one of those things that depends on the industry. It depends on who you are and what data you're storing. So I wouldn't go into that in any more detail. This is an interesting one. Perimeter security model broken. Who knows what the perimeter security model is? Yeah, you're a professor. Okay. Does anyone else know? Yes? Sergey?
Chewy on the inside, crunchy on the outside.
Yes. Sounds like a candy bar, doesn't it? The perimeter security model is a traditional model that says that we're going to protect our enterprise by putting a strong barrier around the outside of the enterprise, and then, well, everybody inside is good, and everybody, the bad people are on the outside. But unfortunately, it turns out that's not true. For any enterprise of any reasonable size, you'll find that there are some bad people on the inside. And not only that, sometimes there are good people who go outside, get their laptop infected, bring it back inside, and then it starts infecting everybody. So the traditional security model for network security was the perimeter security model. You'd put like a firewall here, a demilitarized zone, or DMZ, in between, and then another firewall, and this would be all safe in here because there are nice people at our company and none of them are bad, and none of them ever get infected or anything like that. But over time, we've come to realize that doesn't really work so well, especially with these mobile users who go out and get infected and come back in. And now we have remote users who are sort of like little mini outposts out in the world, and they're like their own little hard, crunchy little area here, and then there's like a secure pipe back in. It doesn't work so well. Well, the news is it just gets worse. With cloud computing, it even works less well. Because what about the cloud? Is that inside or outside? If it's inside, then how come all of our competitors are running software in there? Because that's not really good. So we can't really consider it inside our trust boundary. And if it's outside, then why are all of our most important pieces of data, or at least some of them, outside of our security perimeter? And doesn't that sort of point out the failure of the perimeter security model? So another talk could be about the perimeter security model and how you come up with something else. But the point here is just that neither works. You can't include the cloud or not include the cloud in your perimeter. Yeah, Sergey.
So I would say that one of the reasons why the perimeter model doesn't work is that in order to enforce the municipal policy, you have to model the transactions. across the perimeter, and yet you lack most of the context of these transactions to decide to make the police decision one way or another.
So-
Because the context is at endpoints, not at the crossing point of the perimeter.
So let's talk about this later. Because like I said, that's a whole nother talk about the perimeter security model and why it's broken and what you could do instead.
But I would like to direct this to the alternative, right? How would you model transactions in the cloud?
So I'd be glad to have that conversation. I guess in brief, I will say that you need to have appropriate access controls within the cloud for who is allowed to do what with respect to the cloud and the data that's on it. The question was, if you're not going to use the perimeter security model, what security model are you going to use? And in brief, it would be you need to do your security in a distributed manner, not just at one point at the edge, but at each application, at each service. Each service needs to provide its own security. And then the last item I wanted to point out here is one more threat, which comes about because the cloud computing provider can have its own security systems, and then the customer has their own security systems, and they aren't necessarily integrated. Cloud computing providers generally have their own directory, their own identity management, their own authorization. So, they've got a directory of users, who's allowed to do what on that cloud. And then you've got your own directory of who's allowed to do what in your organization, and they don't necessarily match up. So somebody gets fired, one of your administrators, and you remember to take them out of your directory, but you don't remember to take them out of the cloud computing provider's directory. Now they can still access all of your data and applications up in the cloud, and that's not such a good thing. So it's much better if you can integrate your identity management system. So the cloud computing provider says it gets out of the business of maintaining a list of who your users are, who the customer's users are. Customer maintains their own directory. The cloud computing provider just defers to the customer in that respect. And that way, one directory, one common set of access controls. It's even, the more integration you can do, the better. Like, it's good if you can integrate monitoring and notifications. Then if something bad happens in the cloud, you'd be notified. As opposed to today, where something bad happens in the cloud, one of your users is fooling around and attacking people, and the cloud provider is notified and has to call you on the phone and say, what's this guy doing, and why is he attacking other people in the cloud? Why is he trying to hack our systems? So there's lots of alphabet soup standards that you can use to provide this integration. So just in conclusion, I guess my bottom line on cloud computing security is, first of all, you need to, if you're considering applying it for any particular application, set of data, you need to engage in that full risk management process. Look at your actual data and figure out, how sensitive is that data? What would happen if that data got leaked, or if that data got, lost? Or you need to go through the whole process for every case where you're considering using cloud computing. It might be a good idea to use it for your personal email and your pictures. It might not be such a good idea, and maybe for a Times machine where it isn't really that confidential. Might not be such a good idea for, your top secret information about where all the spies are. For small and medium-sized organizations, your security probably stinks already, so this is probably a step up from what you're doing today, especially if you choose a good cloud computing provider. And if you don't really care about the security of your data, like the two startups that I talked about earlier, where it isn't really their data, it's their customers' data. They upload some pictures, they mess around with it, they make a video. The pictures were already up on Facebook, okay, maybe not a big deal if it got compromised. Maybe for them that's okay. For large organizations, they generally already have their own secure data centers. The main areas where they may want to consider cloud computing would be where they really have to be able to scale up fast and scale down, and they can't realistically afford to build a data center for that maximum peak capacity. And they can live with the security issues inherent in cloud computing, or they're going to find a really secure cloud computing provider, perhaps. internet-facing services, that might be another area. In any case, they probably want to employ some of those countermeasures. And I think more important than anything else that I've talked about today, because cloud computing is a buzzword, and 10 years from now, we're going to be like, oh, yeah, you remember cloud computing? Oh, yeah. Some of the concepts will still be around, just like time sharing, just like push, all these sort of weird trends in the IT industry. So that was an entertaining exercise. But the most important thing I hope that you take away from today's talk is the security analysis skills. Because you need to be able to, in your future career, be able to apply those same sort of structured processes to looking at any new technology and to say, with respect to that technology, what are the assets that need to be protected? What are the threats that needed to be protected against? What are the countermeasures that you can apply? And you can apply that streamlined process that we just applied there. You can apply the whole, complicated, context-specific ISO 27005 or NIST SP 830 or whatever you want to call it. Whatever exact process you want to use. You can apply either the streamlined process or the more complex process, but you should have this ability to think through those issues with respect to any new technology or new project that you're taking on. Because the same process, the same issues apply over and over again. And if you'd like to practice, you can just go out to any IETF RFC or Internet Standard, or even just read about some new technology in a newspaper, and you say, I wonder what are the assets, what are the threats, and what are the countermeasures that could be applied here, and you can do a few of these, Gedanken experiments in your head, and you can, maybe write them up. You could read a few really good ones in some good RFCs. There's even an RFC here, RFC 3552, that talks about how to do this streamlined security analysis process. So being able to perform that security analysis is certainly a valuable skill. And hope you are able to master that skill and take that away. So I think we still have 5 minutes if there are more questions or discussion on this topic.
Any questions for our speaker?
You can ask me about what it's like to work in the industry if you want.
Have you been working on cloud computing, or what is it that, how have you dealt with it?
Good question. The question is, have I been working with cloud computing, or what is my relationship to cloud computing? So I work in a departmental CTO organization. That is, we have within our department, the security department, a chief technology officer, and I report to him. And so he gives me all sorts of assignments. He's like, oh, what is this cloud computing thing? Go off and analyze that. So I go off and analyze that. And then he says, oh, this customer wants you to go talk about cloud computing security. Go on and talk to them. So that's the sort of thing that I do, among other things. But it's sort of, I don't know, odd job kind of thing that he sent me off to work on. Interesting, fun thing to work on. And I'll probably advise some of our product groups that are looking into the problem and what can they do to help our customers who are considering deploying cloud computing. So, question?
Is any Juniper's hardware specifically tailored to cloud computing, or is it all just high throughput network stuff?
The question is any of Juniper's hardware specifically aimed at cloud computing, or is it all, generic high throughput networking and security? It's all generic high throughput networking and security. Now, can you use it for cloud computing? Certainly you can, because it's all good generic high throughput, fantastic quality. I don't know. Yes, you can use it for cloud computing. Are there some things about it that make it relevant to cloud computing? Yes. We have an SDK that you can use to customize our and add additional code to our gear. So that's somewhat relevant. IBM did a recent demonstration of a cloud computing environment, and they were, moving VMs, dynamically across the cloud and replicating them around the cloud, very quickly because they had pre-provisioned high QoS paths for that. So there are things that you can do with our equipment, but it's not, none of it is, we don't have like a cloud computing series of boxes or something like that. We mainly make security and networking gear. Yeah.
It seems to me that cloud computing might increase the demand for standardization and higher IT security standards, and even just auditing of those standards or monitoring or forced compliance with them. And that seems like a very good thing in general because, for example, the small companies you talk about who can't afford to do it, but if they all use the cloud and the cloud is required to do it or has its own interest in having those higher standards, the internet overall is better off, or maybe just those customers. Would you give your views on that?
Yes, yes. So to repeat the comment, summarize the comment, perhaps I should say, which I think is a great one. Cloud computing may drive the demand for standardization in security and raise the bar and provide some high expectations in that respect. And I agree there. I think another thing that cloud computing will do is to improve the overall state of small, medium-sized business security. And in fact, it's my personal view that for a lot of consumers and small, medium-sized businesses, this will be a big and represents a big improvement in terms of security. Like I said earlier, their idea of security is they've got a lock on that closet, but they don't realize all the information security issues that arise. So I do think it's overall a positive thing. I know that I've raised a lot of issues here. To be honest, that's always what happens whenever you do a security analysis of any system. You raise 35 different security issues, if not 350 different security issues. You knock down 10% of them, and the other ones you say, well, there were 35 or 350 different security issues with the last system we deployed, and there always are. You can't solve every security problem. And so I would suggest that you not be necessarily completely deterred and dismayed by the issues that I've raised, because there are as many issues with pretty much every system that we field today. So, yes?
So one of the large troubles that people who want to keep their information secure have with using cloud computing, as you brought up, was that the cloud computing provider has physical access to all these machines, and whenever you have physical access to data, you can get to it. There is some way. In order for people to have more trust in the providers, there needs to be some improvement either in maybe regulation or in some techniques or something like that. Where do you think that extra trust will come from, if it does come?
So to summarize the question, I guess I would say that it in essence is how can users come to trust cloud computing providers? Because that's what they have to do if they're going to use cloud computing. And I guess I would say that that trust will come over time and based on their reputation. Now, could there be regulatory requirements that could be placed? Yes. And there already are regulatory requirements for certain industries, such as HIPAA. And cloud computing providers are in some cases trying to meet those requirements. But I think in general, it will have to come from trust and reputation, and that will be based on their track record. I see that we're out of time. So if you have any more questions, come down afterwards.
Thank you very much.
Thank you.